In the previous video we talked about digital inputs. For example, pressing this button will light up this LED. But what happens if we want to check something that is not digital, meaning it doesn't have on and off, it has a wider range, something that is analog? Well, Arduino got a solution for us. If you find the video useful, please share and like it and subscribe to my channel. Arduino Uno, for example, got 6 analog inputs here marked from A0 to A5 with a 10-bit resolution, which means we will get a number anywhere between 0 and 1023. Now let's wire some things up and see how it works. For this demonstration I set up something really basic. On the left here we got a potentiometer. On the right here we got a LED. The potentiometer is connected, its left leg is connected to the ground, its right leg is connected to 5 volt, and the middle one is connected to A0, analog A0 of the Arduino. On the right side we got a LED which is connected to pin 3, which has PWM capabilities. And now we're gonna take the measurements that we get from the potentiometer and turn that to the brightness of the LED. So if I rotate to the right, you can see the LED is getting brighter. Rotating to the left, and it gets darker. Now let's go see how it works in the code. Okay, so let's go over the code really quick. I defined an output pin, pin number 3, and as I mentioned before, pin 3 has a PWM capabilities. Analog input pin is the A0, and then in the setup I define the output pin as an output. And inside the loop, the only thing I do is I use an int, and it's really important to not use a byte. I called analog value to read the analog read from the analog input pin. And then I use analog write, which writes PWM and not an actual analog value to the output pin. And the reason I'm doing analog value divided by 4 is that, as I mentioned before, the analog value that comes from the analog read will be a 10-bit resolution, which means any number between 0 and 1023. On the other hand, the analog write has a 8-bit resolution, meaning any number between 0 and 255. Therefore, we need to do the math, otherwise we'll go over the value and we'll basically get 4 cycles, but just do this and then you get 0 to 255. Now, as you can see, I marked here 2 lines, which is the serial begin and the serial print line. The reason I'm doing this is that I want to see some information coming out and see what the actual values of analog value is. The reason I'm adding the second line, which is the system started, is that sometimes when you work with COM ports, they don't open well, and you're waiting for information to come from your loop and nothing happens. And you never know if it's an actual bug in your software, a bug in the communication. So what I do is I added this line in the setup. Therefore, at least this line, if I upload this program, at least this line will have to appear when I'm opening the COM port. I'll show you. I'll upload this, and then I'll open the COM port, and we'll see what happens. As you can see, I opened the COM port, and the system started to show up. And now I know that for sure my communication with the board is fine. So now let's output some data. Okay, so now let's add the printout, and let's do serial print line new. And we'll add the analog value. And one thing I do want to do is I'm going to have a delay of, let's say, 100 milliseconds, so we won't have the serial running like crazy and we won't be able to follow. So let's upload this and we'll open the communication port. As you can see, it's outputting data, and if I'll rotate the potentiometer to the right, the value will rise almost, and you can see it gets to 1022. Sometimes you see 1023. That's due to probably the breadboard. It should be 1023 when I get it all the way to the right. Sometimes you can see it jumping and rotating all the way to the left, and I'll get 0 again, and anything in the middle. So it works. So, taking one thing that we learned and let's make something useful. What I did here is I removed the potentiometer and I replaced it with an LDR, a light dependent resistor, and a voltage divider with a 10K resistor. It's the same setup as where the potentiometer was before. I just placed the LDR here and the 10K here in between the 5 volt and the ground, and we're measuring the center in between of them. And what's going to happen is once that measurement goes below a certain number, we'll switch on the LED. Let's write some code and see how it works. So the first thing we want to do is we want to actually see what are the values that comes from that voltage divider in the LDR. So let's open the COM port and see what values we get. So the value we're getting when there's light above the LDR is around the 860, and once I block the light, I'm blocking it with my finger, we're getting anywhere around 400 something, 500, so less than 550, let's say. So let's make some changes in the code and use this value to trigger the LED switched on. So this is the revised code. As you can see, it's the same setup. Only thing I do different here is I'm checking the analog value. If it's less than 600, I'm gonna switch the LED, the pin of the LED to high, turning it on. If it's if it's more than 600, we'll just keep it low. It'll be switched off, basically turning it into some form of a light detecting. And I'll upload the code and let's see how it works. So now, every time I block the light for the LDR, the LED will switch on. Notice I'm blocking the light, the LED is switched on. Removing it, it gets turned off. There you go.